We are now about to start our lesson on conic sections. The first conic section that we will discuss are circles. First, let us define what conic sections are. We abbreviate this as conics. They are just curves that result from the intersection of a right circular cone and a plane. In this scenario, the intersection of your plane and your right circular cone will form a circle. Here you will have an ellipse. Here you will have a parabola, and here you will have a hyperbola. We are going to formally define these three other curves later on. You are all familiar with the definition of a circle. A circle is a set of all points that are at the same distance from a fixed point C called the center. And that fixed distance is called the radius. Now, suppose this is our center C and this is just a point on your circle. Let us derive the formula for the equation of a circle. Suppose that our center is the point HK. The distance between the point XY and HK is our radius, R. From our distance formula, the distance between the 2 points XY and HK, which is equal to R, is equal to the square root of difference of X coordinates plus difference of Y coordinates, Y minus K squared. Hence, when we get the square of both sides, we get that R squared is equal to X minus H squared plus Y minus K squared. We have now derived the equation of our circle with center HK and radius R. This is known as the equation of a circle in center-radius form. Let us find the center and radius of the following circles, and then let us draw the circles. Remember that the equation of a circle is given by this formula. From our formula, the center here is 1, 4, and our R squared is 9, so therefore, the radius is equal to 3. Let us now draw our circle. The center is 1, 4, and since you have a radius of 3, from the center, I will just go 3 units, so that's 1, 2, 3, so you're at 4, 4, and then 3 units to the left, so that's 0, negative 1, negative 2, so you're at negative 2, 4, and then again another 3 units, and here 3 units down. This is now our circle. Next, our center here is negative 5, positive 2. Remember, it's X minus H, Y minus K. So therefore, you sort of reverse the sign here. So this becomes negative 5. This becomes positive 2. Your R squared is 7. So therefore, your R is square root of 7. I will no longer draw these circles. Lastly, X squared plus Y squared equals 16. Our center is at 0, 0. Our R squared is 16, which means that R is equal to 4. Since our center is at 0, 0 with radius 4, this will be sum of the points in your circle. You have these 4 points and connect this by a circle. The general equation of a circle is given by this formula. This only means that you just want one side of your equation to be equal to 0. You just put all of the constants and the terms on one side, and one side must be equal to 0. Now, how do we transform the general equation of a circle to center-radius form? The key to do this is by completing the square. However, when you are completing the square, make sure that you remove the coefficients of X squared and Y squared. And how can you do that? You divide everything by this coefficient. So for example, we want to reduce the following equation to center-radius form so that we can determine the center and radius. The first thing that we have to do is to divide everything by the coefficient of x squared and y squared. So that's 2. We get x squared plus y squared minus 10y plus 5x plus 31 over 2 is equal to 0. To complete our square, let us put together all the terms involving x and all the terms involving y. Moreover, you put all the constants on the other side. So we have here negative 31 over 2. Now take note that I left a blank here so that we can insert our constant. What is it that we are going to insert here? You copy the coefficient of x, divide it by 2, and you square. Similarly, for this one, you divide the coefficient of y by 2, so that's 5, and then you squared. And then, to make sure that you're not changing your equation, you also add the same thing here on the right-hand side. Now we get that x squared plus 5x plus the square of 5 halves is x. You just copy this. That's why I did not write it as 25 over 4. I just left it as 5 over 2 so that you will just copy it. And the sign will be the sign in your middle term. So that's x plus 5 halves. And then here, we get y and then 5. The sign is minus. Then let us expand this. We have negative 31 over 2 plus 25 over 4 plus 25. The right-hand side is equal to 63 over 4. Let me just copy this. Hence, our center is negative 5 halves, 5 from here. And our radius is square root of 63 over 4. So that's square root of 63 over 2. But 63 is 9 times 7, so this is 3. Square root of 7 over 2. Another example, we have 5x squared plus 5y squared minus 15x equals 25. Again, we always start by dividing both sides by the coefficient of x squared. And that coefficient should be the same as the coefficient of y squared if you have a circle. We get x squared plus y squared minus 3x is equal to 5. Let us combine all the terms involving x and all the terms involving y and all the constants on the other side. So we still have 5. What do we add here? We add, get the coefficient of x, so that's 3 over 2 and then squared. For this one, this is already a complete square. So I will also add 3 halves squared on your right-hand side. This 3 terms here is now equal to x. You have a minus here, so this is minus. Copy this. Plus y squared. The right-hand side is equal to 29 over 4. Hence, our center is 3 halves, and then this is y minus 0, so that's just 0, with radius equal to square root of 29 all over 2. Next, let us find the equation of a circle with center negative 2, 3, and radius 4. Express your answer both in center, radius form, and general form. Alright, we're already given the center and the radius, so therefore, in center radius form, this is just x minus negative 2 squared plus y minus the y coordinate of your center is equal to 4 squared, 16. And to write this in general form, all we have to do is to expand the squares here. Square root of x plus 2 is x squared plus 4x plus 4. The square of y minus 3 is y squared minus 6y plus 9. This should be equal to 16. And then we just transpose 16 so that one side will be equal to 0. So that's negative 3. This is now your general form. So remember that in going from center radius form to general form, all you have to do is to expand. But the other way around, from the general form to the center radius form, you have to complete the square. Next, let us find the equation of the circle with center 2, 1 and passes through negative 1, 3. In order to imagine the problem, let us draw it. So I have my circle here. This is the center 2, 1 and it passes through the point negative 1, 3. In order to get the equation of a circle, what is it that we need? We need your center and your radius. We already know what the center is. The center is 2, 1. We just need the radius. But from here, we can easily get the radius. What is that radius? That is just the distance between 2, 1 and negative 1, 3. So we now use the distance formula. That is square root of difference in x coordinates. So that's 2 minus negative 1 plus 1 minus 3. And then squared. We now get 3 squared is 9 plus 4, square root of 13. Hence, the equation of our circle is x minus 2 squared plus y minus 1 squared is equal to r squared. So that's just 13. Next, let us find the equation of the circle with diameter 2, negative 5, and 6, 3. Again, I drew our given. This is our circle with diameter endpoints at 2, negative 5, and 6, 3. As usual, we always need our center and our radius. How do we get our center? The center is just the midpoint of 2, negative 5, and 6, 3. From the midpoint formula, we just get the average of your x coordinates and then the average of your y coordinates. This is equal to 4, negative 1. What about our radius? Note that we already know that this is 4, negative 1. So we can compute our radius by again getting the distance between your center and either the point 2, negative 5 or 6, 3. Actually, I will just compute for r squared so that I no longer have to get the square root because what we need is r squared anyway for the equation of your circle. So this is difference of x coordinates. I'm using these 2 points here, 6, 3, and 4, negative 1 plus 3 minus negative 1 squared. This is 2 squared, so that's 4 plus 4 squared, 16. Hence, our r squared is equal to 20. The equation of our circle is x minus the x coordinate of your center plus y minus the y coordinate of your center is equal to r squared. Next, let us find the equation of the circle with center negative 4, 5 and tangent to the x-axis. Again, let us draw our problem. This is my center negative 4, 5, but it is tangent to the x-axis. So therefore, how will it look like? Your circle is like that. It will touch the x-axis at the point negative 4, 0, which means that our radius is, what is this distance here? That distance is equal to 5. So therefore, 5 units to the right, you will be at 1. 5 units to the left, this is negative 9. 5 units up, this will be 10. 5 units down here. So we have just seen that our center is negative 4, 5, and our radius is equal to 5. Because the circle is tangent at the x-axis, it should touch the x-axis here. Hence, your radius is equal to 5. The equation of our circle is x plus 4 squared plus y minus 5 squared is equal to 5 squared, or 25. Next, this is a bit similar to the previous problem that we had. We are given the center. This time around, it is tangent to the line x equals negative 4. This is my point 2, negative 3, and the line x equals negative 4 is a vertical line passing through negative 4, 0. So, it's this line. How will our circle look like? This means that the circle will touch x equals negative 4 here. How did I go about it? I just construct a perpendicular from this point to the line x equals negative 4. Since x equals negative 4 is a vertical line, I just had to draw a horizontal line. So if we go back to this problem earlier, this was our center and it has to be tangent at the x-axis. The x-axis is a horizontal line, so therefore all I had to do was to draw a vertical line going to your horizontal axis. So therefore by that argument, we get that the radius is, what is this? This is from 2 up to negative 4. The radius is equal to 6. That's 2 minus negative 4. Again, our center is 2, negative 3. Hence, the equation of the circle is x minus 2 squared plus y plus 3 squared is equal to 36. Next, let us find the equation of the circle with center negative 4, 2 and tangent to the line 3x plus 4y is equal to 16. You don't really have to plot your circle. Let's just draw a circle and let's say that this center is negative 4, 2. You don't really have to graph 3x plus 4y equals 16. We just know that this circle will be tangent at this line. So let's just say that this is our line. Again, our goal is to find the radius of our circle because we already have the center to be negative 4, 2. How do we get this radius? Take note that when we are looking for the radius, the distance between these 2 points, that happens to be the distance of the point negative 4, 2 from this line 3x plus 4y equals 16. Hence, we will make use of our formula for the distance of a point from a line. Before we can use that formula, we have to make sure that this is in general form. That is, one side must be equal to 0. We now use the formula. For the numerator, we simply substitute negative 4, 2 for x and y here. All over square root of a squared plus b squared. Your a is 3 and your b is 4. This is negative 12 plus 8 minus 16. Square root of 3 squared plus 4 squared, that is equal to 5. Hence, this is equal to 4. Our radius is equal to 4. The equation of our circle is now x minus negative 4 plus y minus 2 squared is equal to 4 squared. Here are some exercises that you can try.
Thank you for watching. If you are still new to my channel, please press the subscribe and notification bell to be always updated to all my upcoming videos. Thank you. Always at your service. Sir Absolon.
Sa iyong ngiti, ako'y nahuhumaling. At sa tuwing ikaw ay lalapit, ang mundo ko'y